Hello, my name is Rafael Silva. I'm a third-year PhD student at the Mirror Lab, and today I will talk about the paper Worth the Wait, Understanding How the Benefits of Performative Autonomy Depend on Communication Latency. This work was done in collaboration with Lieng, Emil Muly, and Tom Williams from the Colorado School of Mines. Robots hold significant potential for space exploration, not only on planetary and lunar surfaces, but also within space stations and ships. Robots operating in these space exploration contexts need to communicate efficiently with remotely located humans, whether they are also in space or on Earth. However, in these contexts, latency in communication becomes a problem, and the need for efficient communication in space is accentuated by the dangerous character of space exploration. In previous work, Roy et al. Proposed performative autonomy, a strategy in which robots ask questions to increase situational awareness rather than to gather information without cognitively overloading interactants. While in their work, they have shown that performative autonomy is an effective strategy for improving situational awareness and task performance without increasing cognitive load. In this work, we look at whether these effects will remain true when latency is present. This is important because high communication latency is a defining characteristic of remote human-robot interaction scenarios and becomes a bigger interfering factor as space missions move farther away from Earth. In this work, our main research questions are the following. First, how does performative autonomy impact the success of interactions with remote language-capable robots? And second, how does communication latency mediate the effectiveness of language-capable robots' use of performative autonomy? We manipulated two independent variables, latency and performative autonomy strategy. In each task, a Greco-Latin square design was used to determine the combination of parameters for latency and performed autonomy strategy. In our experimental context, the human participant's task was to complete a resource management game in which their continued progress required certain resources to have been previously collected by their robotic partner. At any point during the game, the participant was able to check on what the robot was doing by looking at a camera feedback displaying the robot's remote state. The robot reevaluated its choices every 50 seconds and, if needed, engaged in different types of verbal interactions with the participant. This interaction varied according to the performative autonomy strategy in use. In the low performative autonomy condition, the robot asked participants to help them arbitrate between multiple options. This question followed the format of a WH question. For example, the robot could tell the participant, I was collecting blue resources, should I keep collecting blue resources or switch to red resources or green resources? In the medium performative autonomy condition, the robot asked participants for confirmation on a decision. This question followed the format of a yes-no question. For example, the robot could tell the participant, I was collecting blue resources, can I now switch to collecting red resources? And finally, in the high performative autonomy condition, the robot merely stated its decision. For example, the robot could tell the participant, I was collecting blue resources, I am now going to switch to collecting red resources. In this study, our key dependent variables were task performance, perceived robot dependency, cognitive load, and teaming quality. Our data were analyzed using Bayesian repeated measures ANOVAs with Bayes factor analysis and is publicly available in the OSF website at the following link. For our results, as expected, higher levels of latency led to longer task completion times. In addition, we observed that higher performative autonomy led to lower task completion times. As in the low autonomy conditions, the participants needed additional time to process and respond to the questions asked by the robot. This suggests that while performative autonomy can provide benefits to situational awareness, it may need to be avoided in contexts with serious time constraints. Finally, we observed that larger levels of latency led to bigger differences in task completion times between performative autonomy strategies. This finding reinforces the idea that using performative autonomy might not be a good idea for contexts with high time constraints. So when deciding whether or not to use performative autonomy, we must think about the trade-offs between gaining situational awareness and losing time efficiency. For perceived teaming quality, first, we observed that high levels of latency led to worse perceptions of teaming quality. These results suggest that humans naturally prefer to work with a robot that responds to their input quickly. In addition, we observed that higher levels of performed autonomy led to worse perceptions of team equality. This is likely because robots performing lower levels of autonomy were better able to take human preferences into account and better at demonstrating that they were willing to do so. For perceived robot dependency, we observed that higher performed autonomy led to lower perceptions of robot dependency. These results suggest that humans might be more willing to collaborate with robots that are perceived to be less autonomous, even though that might lead to longer completion times. For the interaction effects between latency and performative autonomy strategy, the primary difference observed is that while under low or high latency, medium performative autonomy produced a perception of high dependency alike to that produced by low performative autonomy, under medium latency, medium performative autonomy produced a perception of low dependency alike to that produced by high performative autonomy. Finally, results for cognitive load revealed strong evidence against any effect of latency and moderate evidence against an effect of performative autonomy or the interaction between latency and performative autonomy. These results reinforce the findings from Roy et al., since they suggest that cognitive load remained unaffected by performative autonomy even when latency is involved. Given these results, it is important to keep in mind the limitations of our study. Most importantly, the latency intervals in remote interactions between Earth and space are significantly larger than the intervals that we use in our experiment. These longer intervals are likely to manifest results that are different from those observed in this study. So future work might investigate the impact of these larger latencies on human-robot communication dynamics. Thank you for watching. If you would like to read more about this work, please read our paper.